Okay, hey, what's up? Now, if you're wondering why I'm in my car parked making this video, is because I came to visit my family during holidays, and there is a 2-year-old baby running around the house, and it is very hard to get any work done there. So I figured I'd just knock this out here. Welcome to the Ambitious Tech Developer. Now, today's going to be a very simple lesson. It's the way approach the planning of the whole object-oriented concept and how to structure, right? So this is before you even lay out any code, before any diagram. It's kind of just like plotting, just thinking about exactly what you're going to do and how you're going to do it. Okay, so chapter 2 of this book, it's called the object-oriented thought process. It's actually just on how to think in terms of objects, okay, and basically how to break everything up. 3 important things will actually be So now 3 important things are actually going to be knowing the difference between the interface and if I could talk. Knowing the difference between an interface and an implementation. Second would be thinking more abstractly. And third would be giving the user the minimal interface possible. What that basically means is not handing out more than you should. Before we start, I actually want to get a couple things that I thought that were very important. There is no single right or wrong way to approach a problem. And there are usually at least many different ways to tackle the same problem. So don't get stuck on that whole, well, it has to be this way. This is the way the pros do it. You know, the whole purpose of this is to be creative. Okay? Do not strive for perfection in the first approach. There will be more opportunities to improve the solution during other iterations. So don't think that everything has to be perfect once you start laying everything down. The foundation, can be changed, you could modify it, you could add things, you know, all this is just to get started. Remember, the one of the first things in life, in general, not just in coding, is to get momentum. Okay, so start action. It's not about planning, it's about execution. But we also have to plan as well. Okay, next is brainstorm and let your thought process to go in different directions. Do not try to conform to any standards or conventions when trying to solve a problem. The whole idea is to be creative. Once again, be creative. Do not think, well, this is the standard. This is the way that the pros do it. This is doesn't look right, doesn't feel right, doesn't look professional. I get stuck into that myself, but let's not get into that. Remember what this book says. Do not try to conform to any standards or conventions when trying to solve a problem. The whole idea is to be creative. Okay? Next one. Focus on the business logic before even considering what computer language you will use. Identify and solve business problems. For example, you can't design a wireless network without wireless technology. Okay, last but not least, at least for these tips, is remember that object-oriented programming and procedural programming work hand in hand. Procedural code is wrapped in object-oriented programming. An object-oriented wrapper is object-oriented code that contains procedural code within. Okay, so we did not cover this in the last chapter, but this basically just states that procedural programming goes within object-oriented code, right? So a method will have procedural loops and if statements and stuff like that, right? So what it's basically saying is don't get caught up on the whole, well, I'm programming in an object-oriented way, so I can't use procedural code. It doesn't necessarily work like that. They go hand in hand. So, okay. So now that we got that done, let's start with the 3 important things to learn. Okay, so 1, knowing the difference between the interface and implementation. Now, this is pretty important because the interface is something that you're going to hand out. That interface is actually something that you're going to allow the user to actually call, right, to have access to. And the implementation is actually the code that would actually make that method or that behavior possible. All right. So an interface is the handle on which a public method is called and is accessible to other classes or objects. Okay. So like I said, that's the handle. Let's say, for example, you have a method called go walk, right? Go walk would be the handle, would be a public, right? So it's accessible to other classes, objects, and or users. Now the implementation is the code of The implementation is the code or other private methods which reside inside the method on which they act upon once it is called. So for example, on the go walk or whatever class that we're talking about, let's say you would have get up and then front leg move left leg, move right leg, and so on and so forth, right? That action would actually be the implementation. And as for example, that's stated on the book, it was, take a car for example, right? The steering wheel will be the interface, right? That's what the users interact with. They know how to drive it. They use the steering wheel, right? The engine of the car in itself would be the implementation, meaning that that's what makes the car run and makes it work. Now, if the implementation changes, it should not affect the interface, right? So as long as I have a V4 engine in my car and something breaks, the mechanic should be able to come in, fix the engine without having to change the interface, the steering wheel to the car. That's very important when it comes down to code, because you want to be able to change the code in itself without having to recode other things because you change the interface, right? So the interface is something stable, something that you want to have and you don't want to change often, but you'll be able to change the implementation of the interface, right? So for instance, if we change the engine from the car from a V4 to a V6, it wouldn't necessarily be a very good practice, because not only would the mechanic have to change different interfaces in the car, but you would have to do a whole lot of other tuning to the car in order for it to work, because you changed the implementation, right? So although you didn't change the interface, the implementation is so drastic that it changes all the implementations. So although it might be useful to actually have a very abstract class, sometimes it's better to just have what is more useful over something very, 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 very broken down, very abstract. Okay, the next thing is providing the absolute minimal user interface possible. Now, to accomplish this, follow these simple rules. Give users only what they absolutely need. Start with as few interfaces as possible. It is better to add interfaces when you know you need them rather than to provide all the interfaces which they do not need. Also, it is vital to create classes from a user's perspective in order to know exactly what they are expecting, what functionality they are trying to achieve, and what are the requirements a class needs in order to be completed successfully. Okay, so I don't think I've said this before, I'm not quite sure, but it's best to actually start with everything private in a class, and then after programming, after keep coding, go back and switch it to public on depending on what you need. That will force you to actually just allow access to what is needed rather than everything that they don't need, right? Okay, so determining the user. In order to determine the user, you got if you ask somebody that, they might actually say the end user, meaning the person that's at the other end, the person that uses the application. Define the user by the roles in which they will use the application. So for instance, in the taxi class, there's going to be two types of users interacting with it, the customer and the cab driver, right? So those are two users rather than just have users in general. Let's be a little bit more specific. Okay, so now object behavior. Object behavior. After we identify all the users, we have to identify all the behaviors of the object. It's okay to be very broad and have a broad list, because not all of the behaviors or the methods will actually survive the final cut. These choices are identified by gathering requirements using various methods such as UML use case diagrams. Okay, so basically just explore, think about all the behavior that class will have, that it should have, and then we'll end up cutting some off after we know we're not going to use anything else. Now, environmental constraints. Take into consideration physical things that will cause limitations for the software. For example, a cab driver might not be able to use a certain bridge if the road is closed. Identifying the public interfaces. Think about how the object is used and not how it's built. For each interface, you must determine whether the interface contributes to the operation of the object. If it does not, perhaps it is not necessary. Keep in mind that a method should have one purpose and one purpose only. Having a method which does multiple things can restrict code reuse and create problems with the logic of the class. Identify the implementation. Technically, anything that is not a public interface can be considered the implementation. It is good practice to use private methods within interfaces to prevent objects from accessing the data of the private method. So this is basically just catch up again. Basically means it's best to add a private method inside an interface so that the other objects and classes actually don't have access to the data within that private method that is inside the interface. So, like I said, it was a very quick and very simple lesson how to think about objects. So remember, knowing the difference between the interface and the implementation. Interface is the handle of the public method which another class or objects will be able to use. The implementation is the code within those methods that actually allow all the functionality and behavior to take place. Thinking more abstractly. Although we could be very abstract, sometimes it's best to create classes or methods which will be more reusable. And 3, give the user the minimal interface possible. Remember, when creating interfaces, best start with as few as possible, and then create some if you need some later on, or create some public, label some public. But first, let's start with everything private, and then we'll switch off when we need it. Okay, so that is it for today. This is the Ambitious Tech Developer, and if you like the notes and you like this content, make sure you subscribe, and also make sure you download these notes because they are free for you to take. Peace, and have a nice one.